Hello and welcome to Maths with El Profe Lo. In this series of videos, we're doing some work with the Chinese Remainder Theorem, and we went over and we said that we were able to solve this particular system by finding the product of the moduli, right? Finding the product of the moduli excluding your particular moduli, right? Finding the multiplicative inverse with regards to our particular moduli for each of those, and then using this summation to find our solution. Okay, so for the next one, practice. Find a positive integer with remainder of 2 when divided by 3, remainder of 1 when divided by 4, and remainder of 3 when divided by 5. Well, what does that mean for us? What that means is we can set this up as some integer that is equivalent to 2 mod 3, equivalent to 1 mod 4, and equivalent to 3 mod 5. Okay? Now, to solve this, we need to find our big M. All right, we need to find our big M, and our big M is equal to 3 times 4 times 5, and 3 times 4 times 5 is equal to 60. We also need to find our particular big M sub i's, which is really just the product of the other moduli. So for this one, it's going to be 4 times 5, which is 20. For this one, it's going to be 3 times 5, which is 15. And for this one, it's going to be 3 times 4, which is 12. Okay? And many times, to simplify the work, people will write this in ascending order of the moduli or in descending order of the moduli, right? So the 3, then the 4, then the 5, so that your m's are easier to calculate. Okay? Now, the next step in solving this is we need to find the multiplicative inverses for each of these. So I need to solve 20x1 equivalent to 1 mod 3. All right, I need to solve 15x2 equivalent to 1 mod 4, and I need to solve 12x3 equivalent to 1 mod 5. Right, I need to find their multiplicative inverses. Okay, so 20 times 1 will not work, but 20 times 2 will. And so I know that x sub 2 is going to be 2, because 20 times 2 is 40, and that's 1 more than 39. Okay? 15 times 1 does not work. 15 times 2, that's 30. That does not work. 15 times 3 is 45. 45 is 1 more than 44, so that works. All right, so this x of 1 is 2, x of 2 is 3. And over here, 12 times 1 is not 1 more than a multiple of 5. 12 times 2 is 24. That doesn't work. 12 times 3 is 36. That's 1 more than a multiple of 5. So x of 3 then is also equal to 3. Okay? Then our next step, we can say, hey, we know that the value or a value for x is going to be given by the sum, right, from I equals 1 to r of b sub I, m sub I, x sub I, which, because we have 3 congruences, we're going to have 3 products in our summation, right? And so we'll start with what are the b sub i's, and that is a 2, a 1, and a 3. What are the cap m sub i's? That is 20 and 15 and 12. Right? And then what are the particular x sub i's? That is 2 and 3 and 3. Right? So that means that my particular solution is going to be given by, all right, well, let's come over here and check this out. What's that going to be given by? If I come on with my calculator, let's clear out what we have. We have 2 times 20 times 2 plus 1 times 15 times 3 plus 3 times 12 times 3. And that gives us 233. Okay. So I work with my 233. So I'm going to have 233, right? Which is going to be equivalent to something mod 60 if I want my least positive solution. And in order to find that least positive solution, well, I can take that 233 and subtract 60 once, subtract 60 twice, and subtract it thrice. And I see that my solution is going to be 53. Right? Or my least positive solution. It really says find a positive integer. Well, 233 would work, but 53 is generally the preferred answer so that you give the least positive one, and we can always double check this. 53 is 2 more than 51. That satisfies the first congruence. 53 is 1 more than 52. That satisfies the second congruence. And 53 is 3 more than 50. Which satisfies the third congruence. Okay, so that is working with the Chinese remainder theorem. And if you have questions, please be sure that you reach out. This has been Maths with El Profe Lo.